Okay, so good afternoon, everyone. My name is Pietro Marini. I'm a senior sales engineering at Nextcloud. And in this half an hour, I would like to speak about you the subject of scaling Nextcloud. So the idea is to go through the architectural models that allow to deploy Nextcloud from thousands to million of users. Okay. If we have a look at the agenda, we can see that we will have a look at the general architecture, and then we will see from a small number of users to a very large number of users with global scale, which will be the deployment models. Joss, our marketing director, already mentioned global scale as the deployment model to choose when we have a really high number of users to host in Nextcloud, typically from hundreds of thousands of users to end up. Okay, and then we will see a summary and if there will be some questions. Some little introduction about myself. My name is again Pietro Marini, and I have about 10 years experience in consulting and mainly in the business intelligence and data analytics sectors. I joined the team in June 2021, and I'm focused on the Italian, Spanish, and Latin American market. Okay. So what is actually technically, what is the stack of Nextcloud? Just before jumping in the deployment models, this is a typical LAMP stack. So Linux as an operating system, Apache as a web server, MariaDB or MySQL as database layer, and PHP as a request execution engine. Okay, then it doesn't mean that it is compulsory to stick with these technologies. Of course, there are variants. For example, we can put Postgres, of course, instead of MariaDB. We can choose another web server such as Nginx. But yeah, this is the idea, is that this is a well-known stack for web applications. Okay. Josh already spoke about the components of the Nextcloud platform, the Nextcloud Hub, also called. But let me quickly review them in order for the listener, the audience, to understand what I'm speaking about later. Okay, so there are main four components. Files is the backbone, let's say, of the platform, and allows the basic sync and share functionalities. The groupware component that includes a mail client, a calendar, and project management applications. Talk, Nextcloud Talk, that is the chat and video conferencing embedded application in Nextcloud. And then there is the Office suite that enables online collaborative editing. So let's start our study, let's say, with the single machine deployments. If you have a look at my slide, you can see that in this deployment scenario, we have a single server that contains everything actually. So the LAMP stack that we just saw, the web server, the database storage, and cache are included in a single server. And then we can, of course, enrich the platform capabilities by adding a Talk server. This is called the Talk High Performance Backend server, and this is actually the service that allows calls with more than a few than a few users, calls and video calls, and also an Office suite server. So in this case, of course, we have typically our customers use some long-term supported Linux distributions such as Ubuntu servers or Red Hat Enterprise Edition and other Linux distributions. This machine, of course, depends on the usage, but a typical, to give you just a rough idea of the resources that we should do to this machine is 4 plus CPUs and 16 gigabytes of RAMs. And this kind of deployment would be able to host about 150 users, okay? About caching, caching can speed up file serving when they are frequently requested, so we can integrate with APCU and Redis. And in this case, we would recommend using the built-in authentication, so you can define users and manage them inside the platform, or use your corporate LDAP or Active Directory server. If we focus a little bit on the Talk high performance backend, this has two main elements. These are the signaling server and the WebRTC web gateway. The signaling server, actually, the main role is to exchange messages between the participants in the call, and the WebRTC gateway is the actual connection hub that gets the media from each participant and broadcasts it to all the others as needed. Okay, so if we have a look at this diagram, we see that the user will access the service through the Nextcloud web server, and then the Nextcloud web server will contact as needed the backend services, and then a connection will be established between the Janus WebRTC gateway to the user. As soon as we go up with the number of users, the best way to respond from an infrastructure point of view is to install a cluster deployment. So actually, in the cluster deployment with up to about 1,000 users, we see here what is the recommended architecture. So put a load balancer. Typically, we use hproxy, but also other load balancer, of course, possibles, with the 2 web servers, 2 database nodes, 1 master and 1 slave, 1 Redis node, and the storage as needed. Okay. Of course, in this case, when you have several nodes, web servers node that are able to get the requests from the users, you will need to have a shared storage. So there are several options here, of course, but to start with, it is okay to use an NFS file system or object storage, with which we have, of course, official support. Regarding memory caching, again, Redis, the point is that our caching, it is separated from the main server, because maybe we can better control the load and the resource allocation there. And regarding the authentication, again, we can integrate with LDAP Activity Directory Server, but for this kind of size for the organization, typically we see that there is also single sign-on, and we do have native integration with single sign-on and different identity providers. Some example of protocols: we support SAML, SAML 2.0, OpenID, and as an identity provider, for example, Keycloak is a common choice with our customer and our use base. Sorry. Okay. What happens when we go up with the numbers? Okay, the slide that we just saw was for about 1,000 users. So to about 100,000 users, this can this number greatly depends on the usage, actually, on the applications that are installed. As Josh mentioned before, there is a huge ecosystem of applications. So this means that huge variability in resources consumption, okay? It is not the same to have an installation with just files installed and an installation with also groupware and also all the related applications, okay? But as a reference number, we can keep this 100,000 users number. All the components then can be scaled independently. If we see, we can add up to 20 web servers, okay, about. We can have also load primary and secondary load balancing with the floating IPs. And also the other components, for example, the Redis cluster and the Office Suite cluster can be scaled up as needed, okay? So, and of course, storage as well. If we focus on the database cluster here, we see that in this deployment scenario, so with many thousands of users using the installation, we will put, it is recommended to put a database proxy or load balancer in front of a database cluster. This means that read and write operation will be redirected to the master, while read operation will be redirected to all the slaves, okay? Some of you may know this technology, max scale or proxy SQL as a possible solution for this, for MySQL and MariaDB, or the equivalent for Postgres SQL. That is, these are the two main supported databases, Postgres and MySQL or MariaDB, and also for enterprise customer, we do support Oracle. Regarding the Talk HPB, it can be also be clustered to offer both high availability and to be able to handle with the load generated by a larger number of users. Both the signaling server and the Janus WebRTC server can be scaled horizontally, actually. So as we already mentioned, then at a given point, we see that you can't really scale horizontally clustered applications, and the reason is that the database cluster can become a bottleneck in the sense that once you reach a given number of nodes, that is 4 typically, then adding more nodes doesn't add actually any performance benefit. Also, the database and other components, but maybe probably the database and the storage can be very expensive to maintain when you have huge instances, okay? Let's, for example, think about a maintenance operation on the database in which you have to, for example, migrate data to another instance. This means that if there is some service interruption, this will be proportional in somewhat to the size of the database. And also, when we have a very large installations, it is probable that our user base is spread around different countries, and we can have legal regulations to comply with. Okay. This is our, let's say, answer to this situation. It is global scale. That is a system, a way to deploy Nextcloud at scale to millions of users. It improves the performance by storing the data next to the users. It keeps data close to the user in a specific location. And this means that you can meet, the organizations can meet external and internal, being them legal requirements, okay? global scale also allows to expand and shrink the deployment if needed. And we will see that as it runs on commodity hardware, it allows to keep the costs under control. Okay. But let's have a look. Before having a look, let's see the use case. For example, we have research networks that have multiple institutes in different countries with different teams. This is a very good use case for global scale. We have large multinational companies that have location all around the world and in which employees are office-based and the main actions that they do on their file is on their local file. They may have also interaction with other departments, but the bulk of the activity is done on their local files, so that we can keep the data close to them and also meet internal requirements. Another use case is the companies with a very large customer base. We are speaking about millions of customers. Let's think about, for example, telecom operators that may want to share a cloud storage service with all their customers. Okay, so these are very good use cases. There may be others, but these are the one that we highlight today. So let's focus on the components. Okay, so we have three main components in a global scale architecture. We have the global site selector, and this is actually the Nextcloud server that the users connect to when they access the service. It serves just as a login interface, and it has an app called Global Site Selector installed. Okay. The second main component is the lookup server. This is a standalone server that stores all user records. Okay, so actually, when a user connects to the global site selector, it gets redirected to lookup server that knows where the user is defined. Okay, in an individual Nextcloud instance. Okay, and this is the third component. Okay. We have as many Nextcloud instances as necessary. Okay, these are small or otherwise said reasonably sized single or clustered instance that runs on commodity hardware. And this is actually the runtime environment for the user. So it hosts the file sync and share, the user activity, etc., etc. Cross-instance sharing is possible thanks to federated sharing, and technically these Nextcloud instance beyond the application that serve the users, they have also the GSS app, so the Global Site Selector app installed in slave mode. This allows communicating with the Global Site Selector master. Okay, so a way to see global scale actually is federated Nextcloud instances with a common access point. Okay, so this is the main point of global scale. And if we have a look at the general architecture, we see that when the user connects to the GSS, it gets redirected to the proper node via a lookup query. As I said, this architecture offer limitless horizontal scalability, in the sense that if we want to expand the platform, it is just a matter of creating a new global scale node. In the diagram, this is one node, this is another node, and this is another node that is as a opacity because it may be there or not. Okay. Regarding authentication, we can use built-in or LDAP, and also if we have a single sign-on system in our organization, we can use SAML. And other computer resources that we already spoke about, Talk HPB, the Talk High Performance Backend, and the only online office suites can be, of course, shared among the nodes. Okay. One of the main benefits of global scale is that maintenance is easier because you are to maintain reasonably sized nodes. Okay, this means that upgrade operations, maintenance operation will be shorter and will not impact the whole user population of the installation, because you can schedule your maintenance operation one per node, for example. Okay, and federation guarantees also a cross-node sharing. Okay, so the whole idea is that users can easily share, not depending on the node where they are located. Okay. So here there is just a nice visualization of what is the main concept of global scale. You have one site in a given geographical location. This site is a manageable Nextcloud instance, okay, or a clustered instance, and then growing the company or growing the need of using Nextcloud in the organization, this can be scaled up globally. Okay. Let us see quickly what will be the sharing process in global scale, just to give a little dive, let's say, in a more technical topic. So we have a user types, user typing the name of the recipient in the shared dialog. This is the normal shared dialog, actually, the plain shared dialog. Oops, sorry. The search queries is sent to the lookup server, because the lookup server, if we recall, contains all the username of the global scale installation and knows where to redirect the share. Okay, so the lookup server will return the search results to the Nextcloud instance that originated the request. The user chooses then the recipient and sends the share request. And finally, if the recipient accepts the request, it will be a WebDAV mount. That is the way that is behind the federation in the original server. Okay, to go to a conclusion, the summary is that Nextcloud can be deployed for organization of any size. We saw some numbers, thousands, hundreds of thousands, and millions of users. The main driver to get the ideas on deployment sizing is the number of active users. This greatly depends again on the actual usage of the platform, but this is roughly a good starting point to start thinking about the infrastructure. The single instance deployment is adapted for about 100 users, 150 users, maybe a little bit more. And the cluster instance deployment then is adapted for the range from 1,000 users up to 100,000 users, and it can be scaled down or up accordingly. Okay. Once we get to these numbers, then we can use global scale that is fit for very large deployments. And we saw a little bit the idea of behind the global scale and what are the main benefits of this deployment. The main benefits are that it enables Nextcloud to scale to millions of users. It is cost efficient as it builds on community hour. Maintenance is, generally speaking, simpler because we are dealing with small instances, and it can help with the data location compliance regulation, in the sense that we can keep the data close to the users. This also has the added benefit that it will improve performance. A part of the fact that it's horizontally scalable, it also, the good point is that it also feels like a single instance. Okay, so the users, no matter in which node they are, they will access the same URL and the same service. We have 4 minutes left by the original schedule, so maybe if there is some question, you can just ask in the chat. I'm not sure, but it seems that there is just one participant.
Okay, Pieter. Thank you.
Hello.
Yes, hello. And maybe one question from other chat. So, how many? What is the biggest installation you see? How many millions, maybe users can handle Nextcloud? So,
Yeah, actually, thank you, Alexander, for the question. We have a huge installation for a telecom operator operating in Central and Latin America. And I think this installation has several 100,000 users, but with plans to go up to more users. That they are now thinking about deploying the service also for businesses that will grow more this number. As I said, one of the features of GlobalScale is that it can be scaled up. So even if not currently you have millions of users, you can be confident that with the GlobalScale you can go up to this number.
I see. Do you have some integrations with load balancers or things like this? Maybe geo load balancer or anyone?
Yeah, load balancer actually are, let's say, an integral part of the infrastructure, but for us is like an external component, in the sense that they just need to serve HTTP requests for the web server node. So yeah, I mean, there are maybe in the field there are more load balancers that are more used than others. I mentioned, for example, HA proxy, but as far as you know, no specific integration with a part of serving HTTP requests and serving them in a performant way.
Okay. If anyone have a question, they can join to audio.
Okay.
Task. If not, so I believe we got the technical things and good that we can scale this, because in our market also we see organizations who can different departments and need to scale across country in different regions, etc.
Yeah, actually, yeah, this is a very good use case for global scale. Okay, because as I explained, you can have local offices, local installations, and then via federation you can deploy the service globally. Okay, so
Okay.
yeah.
Yes.
Okay. Is there any other question?
No, I don't see.
Okay.
No.
Thank you very much.
Mhm.
Thank you for the attention. See you soon. Bye bye.